So job 1, for example, we have 2D space xy coordinate system here, and vector r has components, I don't know, 3, 2. So it means that x coordinate is 3 here, y coordinate is 2. So if I introduce two vectors I and j here, the basis vectors, since that we don't have z direction, we are working with 2D space, we can put I as a 1, 0, I drop the third coordinate here, third component here, and j vector can be represented as a 0, 1 vector. So r I can put like down like 3 times I plus 2 times j. For example, I want to pick out new system of okay. For example, I want to rotate xy coordinate system by angle alpha. Counterclockwise. X prime, y prime here, and here I have alpha angle. So I want to have vector r rewrite as through the new what's components has r vector, r x prime and r y prime in the new system of coordinates. How can I do it? So the first one thing here, I have r as a summation rx I rx times I plus ry times g. Okay. In the new system of coordinates, the same vector r has new components. X component new times I do not like r prime x times I prime plus ry prime times j prime. I prime and j prime, I use this green ink. They are unit vectors, basis vectors, I prime and j prime. They are basis vectors in new system of coordinates. If I can write down the I vector and j vector through, I do not like x times a new system, new vectors. And J through the new system and new basis vectors G, and put this ij into the formula for radius vectors y and j. I really can define the components of the vector in the new system of coordinates. Let's calculate this one thing. I want to zoom in this system of coordinates. So I have firstly my previous system of coordinates, and here I have rotated one. X prime, y prime. I want to continue here, x and y. Here we have an angle alpha. So to define components of the I in the new coordinate system, I have to take its length and multiply by So if I have here I vector, I can calculate its components in new system of coordinates as a projection in the direction x prime. So because the length of the I vector is 1, I have here ix is length of the I. We can use the same rule as a cos-a. So this here ix is a adjacent side, so I can use here cosine alpha. Iy equal the projection in the direction y prime, but you can see that it is a negative direction here, so we have minus length of the I times sine of the alpha. So ix, since that equal cosine alpha, because the magnitude of the I vector is 1, it is a unit vector, and Iy consequently equal minus sine alpha. The same one thing I can do about j vector. J vector, the gy equal magnitude of the g times cosine alpha, and g x equal magnitude of the g times sine of the alpha, and it's equal cosine alpha, gx equal sine alpha. So I can write down that I with new components in the new coordinate system is ix cosine alpha times I prime, Iy equal minus sine alpha j prime, and j vector is sine alpha times I prime minus plus cosine alpha times j prime. If I put I and j into the formula for radius vector, I have r equal rx times. Instead I have to put cosine alpha I prime minus sine alpha prime j plus ry, I forgot put here prime sine bar sine, plus ry times what do I have here, sine alpha I prime plus cosine alpha prime j prime. Next, my work here, I have to gather together the elements with the same factors I prime and j prime, and I have that radius vector is a new system of coordinates is rx cosine alpha plus ry sine alpha times I prime plus minus rx sine alpha plus ry cosine alpha times j prime. So I can say that these factors are components of the vector r in new system of coordinates obtained after rotation of the given system xy system of coordinates by angle alpha. So we have these components rx, ry, and rx, ry here. We know them, they are given one. They are, for example, we had here kind of 3, 2. So you can put this 3, 2 into this formula, and if you know the alpha angle, for example, I don't know, 20 degrees or 30 degrees, you can put over there all numbers and you will have these components here. So see you later. Bye bye.